Always hearing about the next big earthquake, and now scientists are warning that areas around the San Andreas Fault could see a strong earthquake as soon as this year.
The San Andreas Fault is a colossal geological feature stretching over 800 miles through California, marking the boundary between the Pacific and North American tectonic plates. Known for its potential to unleash devastating earthquakes, it has long been a subject of scientific scrutiny and public concern. Recently, NASA has issued an alarming warning about this notorious fault line. Utilizing advanced satellite imagery and GPS data, NASA has detected a rapidly accumulating strain within the fault, indicating an imminent risk of a catastrophic earthquake. Some areas are showing stress buildup up to 10 times faster than previously estimated, with the potential for a massive. This fault is not merely a single crack, but a complex system of faults that have shaped the landscape and seismic activity of California for millions of years. The San Andreas Fault is divided into three main segments: the northern, central, and southern sections. Each of these segments has distinct seismic characteristics and historical activity. The northern section stretches from Cape Mendocino to San Juan Bautista. The central section runs from San Juan Bautista to Parkfield, and the southern section extends from Parkfield to the Salton Sea. One of the most notable historical events associated with the San Andreas Fault is the 1906 San Francisco earthquake. With a magnitude of 7.8, this earthquake caused widespread devastation, including over 3,000 deaths and extensive fires that consumed much of the city. The ground displacement reached up to 20 motion between the Pacific and North American plates. The Pacific plate moves northwestward at a rate of about 2 inches per year, while the North American plate moves southward at a slower pace. This lateral motion creates significant stress along the fault line, leading to the buildup of strain that is eventually released in the form of earthquakes. NASA's recent findings have raised concerns about the potential for a major earthquake in the near future. Using data from GPS stations and satellite imagery, scientists have observed a rapid accumulation of stress along certain sections of the fault, particularly in the southern portion. This area, which runs through the Coachella Valley and the Salton Sea, has not experienced a major earthquake since 1680, making it particularly vulnerable. The San Andreas Fault is not a singular continuous line, but a network of physical landscape and the societal response to seismic hazards, leaving a legacy of devastation and resilience. California's seismic history is punctuated by significant events that underscore the region's vulnerability to seismic activity and the ongoing efforts to mitigate its impacts. Among the most devastating earthquakes in California's history is the 1906 San Francisco earthquake, a catastrophic magnitude 7.8 event that struck the San Francisco Bay Area. The quake and ensuing fires claimed over 3,000 lives and left more than 200,000 people homeless. This event stands as a stark reminder of the destructive power of seismic activity along the San Andreas Fault, emphasizing the need for preparedness and resilient infrastructure. Nearly a century later, on January 17, 1990, and spurred significant improvements in building codes and structural retrofitting practices. California's seismic history offers crucial insights into earthquake recurrence intervals and the accumulation of stress along fault lines. For instance, the 1906 San Francisco earthquake occurred after a period of relative seismic quiescence, illustrating how long intervals between major earthquakes can allow stress to build up, leading to more powerful and destructive events when rupture occurs. Similarly, the southern segment of the San Andreas Fault has not experienced a major earthquake since 1857, raising concerns about the potential for a significant event in the future. The state's response to past earthquakes has been instrumental in enhancing seismic risk assessment and preparedness. The 1933 Long Beach earthquake of seismic activity and its potential impacts. This knowledge informs ongoing efforts to improve earthquake resilience through public education, early warning systems, and community preparedness initiatives. NASA's recent findings. Recent findings from NASA regarding the San Andreas Fault have sparked interest and concern, highlighting ongoing research into seismic activity and its potential implications for California and beyond. While there isn't a specific warning, recent scientific studies have provided valuable insights into the fault's behavior and potential seismic risks. NASA's involvement in studying the San Andreas Fault primarily revolves around utilizing advanced satellite technology and ground-based sensors to monitor ground deformation, fault movements, and related geological changes. These efforts are crucial for an overall stress and strain along the fault, potentially influencing the likelihood of larger seismic events in the future. NASA's Earth Science Division, in collaboration with other research institutions, also monitors changes in ground elevation and surface deformation using techniques like interferometric synthetic aperture radar, INSAR. This technology allows scientists to detect subtle movements along fault lines and understand how stress accumulates and releases over time. Moreover, NASA's Jet Propulsion Laboratory, JPL, has been instrumental in developing models and simulations to predict earthquake behavior and assess seismic hazards. These efforts integrate data from satellite observations, field measurements, and geological studies to enhance the accuracy of seismic risk assessments. Reach efforts concerning seismic hazards. By disseminating research findings and promoting earthquake preparedness strategies, NASA aims to empower communities to mitigate risks and enhance resilience to potential seismic events. New fault line discovery. The recent discovery of a new fault line adjacent to the San Andreas Fault has sparked considerable interest and concern within the geological community and among the public. This discovery marks a significant advancement in our understanding of seismic activity and tectonic processes in one of the most seismically active regions in the world. Located in close proximity to the San Andreas Fault, which stretches approximately 800 miles, 1,287 kilometers, through California, the new fault line was identified through advanced geological surveys and imaging about its potential interaction with this major fault system. Understanding the relationship between these fault lines is crucial for assessing seismic hazards and improving earthquake preparedness in the region. The implications of this discovery are profound for both scientific understanding and public safety. Geologists are studying the orientation, movement history, and potential for future seismic activity along the new fault line. This information is essential for developing more accurate seismic hazard models and updating building codes to enhance structural resilience against earthquakes. The discovery also sheds light on the complex dynamics of fault systems. Fault lines like the San Andreas Fault are not isolated but often interact with nearby faults in ways that can influence earthquake behavior. Steps to secure buildings and infrastructure against potential earthquake damage. Moreover, the discovery highlights the ongoing evolution of Earth's crust and the dynamic processes that shape geological landscapes over time. By studying the characteristics and behavior of newly discovered fault lines, scientists can improve their understanding of past seismic events and better predict future earthquakes. Scientific community response. In response to the discovery of a new fault line adjacent to the San Andreas Fault, the scientific community has exhibited a mixture of intrigue, caution, and a heightened sense of urgency. This finding, made possible through advanced geological techniques and imaging technologies, has sparked extensive discussion and proactive measures within the field of seismology and earth sciences, and influence each other's seismic behavior. This interaction is crucial for accurately assessing earthquake risks and improving preparedness measures in the region. Geologists and seismologists have mobilized swiftly to conduct further research into the newly discovered fault line. Detailed geological surveys, including the use of LiDAR technology and satellite imagery, are underway to map the fault's precise location, orientation, and potential movement patterns. These efforts are aimed at developing a comprehensive understanding of the fault's characteristics and its implications for seismic hazards. The scientific response also emphasizes the need for collaborative efforts among researchers, government agencies, and local communities. Open communication and data sharing are essential for integrating new findings into existing seismic hazard assessments and emergent, with interactions between different fault lines shaping regional seismic activity over long time scales. The scientific community's response includes ongoing monitoring of seismic activity in the vicinity of the new fault line, using seismometers and other monitoring devices to detect any signs of increased seismicity or